Hi guys, so welcome to today's lesson, and what we're going to start with are a couple warm-up problems. So go ahead and try that one. And hopefully you went through the 4 steps that we learned to plot, find theta, find r, find theta, and make your answer. And here's what my work looks like. So when I went to plot, I found out I was in quadrant 4. R is going to come out to 2 and use the formula. If you recognize that you have the ratios for 30, 60, 90, you feel free to skip to r equals 2 here. And then for theta, I ended up with 5 pi over 3. And here's my answer. For your answer, you do not have to use 5 pi over 3. You can use anything that's coterminal. So you could have negative pi over 3 in both of these locations, or you could also have 300 degrees in both of those locations. Let's go ahead and try a second warm-up example. Your second warm-up example is to rewrite that in standard form. Okay, here's our answer in standard form. You should get negative radical 3 over 8 plus 1/8 I. And if you are able to find the cosine of 5 pi over 6 and the sine of 5 pi over 6 without showing any work, that's fine with me. If you use the unit circle and you can do that in your head, that's great. If you do show work, that's fine as well. So if you are doing quadrants and reference angles, it's fine to sketch the angle, find the reference angle, and work everything out on the side. No problem. For today's lesson, which is day 2 of section 6.5, we are going to be multiplying and dividing complex numbers that are in trig form. So to begin, I've given us 2 complex numbers, z sub 1 and z sub 2, that are in trig form. And notice that the r value for z sub 1 is r sub 1, and the r value for z sub 2 is r sub 2. And the theta value for z sub 1 is theta sub 1, and for z sub 2, it's theta sub 2. Now, one thing you might be asking is why use all these subscripts? Why not just use theta here and beta here? Well, the textbook uses these subscripts, and it's also good practice if you're going to continue in a math-related field to start getting used to the subscripts. So I'm going to go ahead and use them today. Now, here's your formula for multiplying complex numbers that are in trig form. If you want to multiply this complex number and this complex number together, then what you do is you do r sub 1 times r sub 2. And then inside these parentheses, you're going to have cosine theta sub 1 plus theta sub 2 plus I times theta sub 1 plus theta sub 2. And that looks like a crazy, big, scary formula to try to memorize. But if you take another look at it, it actually shouldn't look that bad. It has the same structure as our complex numbers in trig form. We have a number out front. It happens to be a product here. And then we have a cosine plus I sine that looks just like this. These are cosine plus I sine. But the angle in here is just theta 1 plus theta 2. So if you recognize that this has the same structure, that it's a number out front, parentheses, cosine of an angle plus I times sine of the same angle, then all you actually need to remember is that you're going to multiply the r's and you're going to add the thetas. You don't really have to memorize this formula. You just have to know that it maintains the same structure. So continuing to our first example for multiplication, we are going to find the product and give our answer in trig form for this example. So here's my first complex number in trig form. The r is 1.2, the theta is 5 pi over 3. And here's my second complex number in trig form with an r of 3 and a theta of pi over 9. So applying that formula, what we're going to do is we're going to start out by multiplying the r's, and then I'm going to have the same structure as before. I have cosine of some angle plus I times the sine of the same angle. Now what we're going to do to get the angle is we're going to add the angle from this trig complex number and the angle from this complex number. So we're going to be adding 5 pi over 3 plus pi over 9. And it's the same thing in here. So if you go ahead and calculate on the side what 5 pi over 3 plus pi over 9 is, you're almost be done simplifying. So if we get this into ninths, we can multiply this by 3 over 3, and that'll be 15 pi over 9 plus pi over 9. and that's going to make 16 pi over 9. So if we go ahead and multiply the r values and simplify this addition problem to give us 16 pi over 9, then we are finished because we have our complex number in trig form. That's it. Multiply the r's, add the thetas. Moving on to our next example. I switched this over to degrees because why not? We're going to find that product, and then we're going to give our answer in standard form. To find the product, we're going to multiply the r's and add the thetas. So what I have written right now is actually incorrect. I do have the product of the r's, and I am adding the thetas, but the parentheses are missing right here, and they matter right now. Because right now it says cosine of 170. We want the cosine of that sum. I actually want to have the cosine of 240 instead. So just a small note for you about those parentheses. 5 times 6 is 30, and 170 plus 70 is 240. I no longer need these parentheses that I had inside because now I just have that one angle. If you wanted to put parentheses around that, you could. Doesn't have any impact at this point. So go ahead and evaluate the cosine of 240 and the sine of 240. Watch those SIGNs. And then if you distribute in the 30, you're going to end up with the answer that you see here. Up next, we are going to investigate a formula for division. And the good news is, if you think about your formula for multiplication and what you do with the r's and what you do with the thetas, I bet you can figure out the formula for division. What we're going to do is divide the r's. Be careful, it does need to be the first one over the second one because division is not commutative. We're going to maintain the same structure with cosine plus I sine theta. So cosine plus I sine theta. But what we're going to do is subtract the thetas. And again, please be careful. Since it's z sub 1 over z sub 2, it has to be theta sub 1 minus theta sub 2. Okay, so make sure you do first theta minus second theta. And again, the formula looks like it's kind of scary, but if you realize all you're doing is dividing the r's and subtracting the thetas, you're in good shape. Just be careful, because when you are doing the subtraction of the thetas, it might be tempting to put a minus there instead of a plus, but that should be a plus. Same as it is in this trig complex number in trig form and this one here. So for our last example, we are going to find the quotient and write our answer in trig form. So here's our first complex number in trig form, and here's our second one. We are dividing. That's what the fraction bar says. So what we're going to do is divide the r's and subtract the thetas. So if we divide the r's, we're going to have 12 over 8. And we're going to reduce that in a moment. And then our structure is cosine plus I sine. We're going to do 3.8 minus 1.1. And I'm going to go ahead and simplify that right here, because I can do that in my head pretty quickly. So I might as well simplify that even in that one step. And if I just simplify the fraction that I had out front and just change this into the 2.7, we now have our answer in trig form. Okay. And that was our last example for today. This last part of the lesson, it's up to you if you want to write it down or not, but in Edpuzzle, unfortunately, or fortunately, I guess, you do need to watch it. You know me, I can't just plop a formula into your notebooks and leave it at that. It's important to me that you know where these formulas come from. So what we're going to do next is we're going to derive the formula for multiplying complex numbers in trig form. And again, if you're not interested, don't write it down. You honestly don't even have to pay much attention right now, but I just can't leave it out because I think you should see this. So I have my two complex numbers in trig form, and we already know what the result is. We're going to end up using the product of these and then the sum of the thetas. But I want to show you how to get that formula. So to get that formula, what we do is we set up the multiplication. So I'm going to take this first one times the second one. And using the commutative property, I can go ahead and move the r's out next to each other. And now the rest is up to us. So look and think, what can we do? You might not want to do it, but you can do it. And that's FOIL. Be very careful with your subscripts as you continue. First times first will be cos theta 1 times cos theta 2. The outers, if it's okay with you, I'm going to write, instead of cos theta 1 plus I sine theta 2, I'm going to write I cos theta 1 sine theta 2. Just like to have the I out front. And then for my inners, I'm going to have plus I sine theta 1 cosine theta 2. And for last times last, I have I sine theta 1 times I sine theta 2. So that's going to be plus I squared sine theta 1 sine theta 2. Now, one thing I think you probably see right away is that you want to change the I squared into -1. I hope you see that. Okay, so we're going to make that change in just a moment. But this is an awful lot of writing. So while we make that change, I'm going to suggest one more thing. And that's to rearrange the terms. You notice that these two have I, and this one's not going to. So what I'd like to do is keep this first term up front. That's one term. And then at the same time that I change the I squared into -1, I'm going to move sine theta 1, sine theta 2 up to the front. And you know what? I don't really need that 1, do I? And then I'm going to take these two terms that have an I and move those to the back. And if you look and think, you might see something that you'll probably be surprised to see today. And that's your angle sum and difference formulas. Do you see cos cos minus sine sine? That is your cosine angle sum formula. Sorry, I misspoke. So when you have cos cos minus sine sine, it's going to be cosine of an angle plus another angle. And that first angle is theta 1, and that first angle is theta 2. And I think you can see that this is coming together. We're actually getting pretty close to that formula. Now for these two terms over here, I bet you can figure out a couple things we might want to do. One is to factor out the I. And you know what? I'll give you a hint as we do that. If we factor out the I, and you just kind of rearrange these two right here, it might be easier to see what you're looking at. And what you have there is sine cos plus sine cos. That's your sine angle sum formula. So I love deriving this formula because I think it's pretty cool that this unexpected appearance of the cosine angle sum formula and the sine angle sum formula. And here I could write theta 2 plus theta 1, but just for consistency, I'm going to write theta 1 plus theta 2 because it's the same anyway. And there is your formula for multiplication. If you're interested in trying to derive the formula for division, it's a bit more challenging. It's actually quite a bit more challenging, but it's pretty cool. So if anyone wants to try it, feel free to contact me if you succeed, or contact me if you have a question. I can give you hints as you go. And to derive the division formula, you would start with this. And you can pretty easily separate the R1, R2 out front, and I'll leave it there for you. If you want to try to derive that division formula, let me know if you have any questions with it.